will be discussing about the armature reaction in alternator. The topics to be covered are armature MF characteristics, that is what all characteristics does it possess, armature reaction introduction, then the armature reaction for different types of load, unity power factor, zero power factor in case of lagging load, and zero power factor in case of leading, and finally the summary and the conclusion. The armature MMF characteristics. In a three-phase machine, the MMF wave is sinusoidal and it moves synchronously with the respect to the stator. This MMF wave is fixed relative to the poles. Its amplitude is proportional to the load current and its position depends on the power factor of the load. The armature MMF remains constant with time. The armature MMF lags the main field MMF by 90 degrees and it is distortional in nature. So it rotates synchronously around the armature, that is the stator. So how does it affect? The effect of the armature flux on the flux produced by the field ampere turns is called the armature reaction. So the armature flux and the flux produced by the rotor ampere turns rotate at the same speed, that is the synchronous speed, in the same direction also. Therefore, the two fluxes are fixed in a space relative to each other. And the modification of the flux in the air gap due to the armature flux depends on the magnitude of the stator current and on the power factor of the load. So, it is the load power factor which determines whether the armature flux distorts, it opposes or helps the flux produced by the rotor field. The three cases considered for armature reaction will be when the load is unity power factor, when load power factor is zero lagging, and when the load power factor is zero leading, that is the capacitive load. So for the resistive load, it is the unity power factor. It is connected across the terminals of the alternator and the current in the conductors are under the influence of the field poles as shown. So the armature flux is clockwise due to the current in the top conductors and anti-clockwise in the bottom conductors. You can apply the right hand thumb rule to find out the direction of the field, and as per that, the direction of the currents, again the cross means the current is entering into the screen and dot means the current is coming out of the screen. So you can find out the direction of the field due to the armature. So the armature field is perpendicular to the main magnetic field and produces a cross magnetizing effect. We have shown by the vector over here, that is FA is in the direction from right side to left side and FM is the direction, that is this is the armature field FA and this is your main field FM, that is due to the field flux, what is the flux being produced. It causes the same effect as it is caused by a pure inductance. So at unity power factor, the effect of armature reaction is merely to distort the main field. There is no weakening of the main field and the average flux remains the same. Since the magnetic flux is rotating due to the stator currents and it is in synchronous with the rotor, the flux distortion remains the same for all positions of the rotor. Now, when the load power factor is 0 for an inductive load. So, when a pure inductive load is connected across the terminus of the alternator, the current lags by 90 degrees to the voltage. This means that the current will be maximum at 0 EMF and vice versa. The EMF as well as current in phase R is maximum as the given position. So when the alternator is supplying a purely inductive load, the current in phase R will not reach its maximum until the N pole advances by 90 degrees electrical as shown in figure B. Now you can see the field direction has been changed and it is lagging by 90 degrees. So the armature field acts in the opposite direction to that of the main field and therefore produces a demagnetizing effect. When the armature field lags behind the main field by 180 degrees, as it lags 90 degrees because of a pure inductive load and 90 degrees because of the armature reaction. Therefore, at 0 power factor lagging, the armature reaction weakens the main flux, that is, it is in direct opposition to the main flux. Hence, this will cause a reduction in the generated EMF. the armature reaction when the load power factor is 0 but the load is capacitive now. So for a pure capacitive load connected across the terminals of the alternator, the current in the armature winding will lead the induced EMF by 90 degrees. The EMF and the current is in phase and is maximum in the position in figure A. So when the alternator is supplying a pure capacitive load, the maximum current in phase R will occur 90 degrees electrical before the occurrence of the maximum induced EMF, and therefore the maximum current in phase R will occur if the position of the rotor remains 90 degrees behind as compared to its position under the resistive load. So the armature field acts in the same direction as of the main field and therefore produces a magnetizing effect. It is just in addition to the main flux. The armature field, which was supposed to lead the main field by 90 degree due to capacitive load, is actually falling back by its original position due to armature reaction. Therefore, this causes an increase in the generator voltage, and therefore at 0 power factor leading, the armature reaction strengthens the main flux. So now we'll try to summarize it with the help of the waveforms. When the alternator is loaded, the armature flux modifies the air gap flux. Its angle, that is electrical angle with respect to the main flux, depends on the load power factor. When the load power factor is unity, the armature reaction is wholly distorting. So you can see for the unity power factor over here, the 90 degree phasor difference between the armature flux and the main flux. The result is that the flux will be strengthened at the trailing tips and it will be weakened at the leading pole tips, so that will be the distortion of the total flux. However, the average flux in the air gap remains unaltered. But when there is a lagging 0 power factor load, that is total and inductive load, the effect of the armature reaction will be wholly demagnetizing because there is a 180 degree phasor difference, so it is in direct opposition with each other, and therefore it reduces the air gap flux and hence the generated EMF. Now, to keep the value of the generated EMF the same, the field excitation will have to be increased to compensate the weakening of the air gap flux. So, when the load power factor is 0 leading, the effect of the armature reaction is wholly magnetizing, so considerably increasing the air gap flux and therefore the generated EMF. So to keep the value of the generated EMF the same, the field excitation will have to be reduced, just opposite of the inductive load. So for intermediate values of the load power factor, the effect of the armature reaction will be partly distorting and partly weakening for the inductive loads, because for capacitive loads the effect is partly distorting and partly strengthening. But practically we have got the inductive loads for the practical generators. The above discussion reveals that the armature reaction flux will be constant in magnitude and rotates at synchronous speed. When generator supplies a load at unity power factor, the armature reaction is cross magnetizing. When generator supplies a load at 0 power factor lagging, the armature reaction is demagnetizing, and when a generator supplies the load at 0 power factor leading, that is pure capacitance, the armature reaction is magnetizing. So in all the cases, if the armature reaction flux is assumed to act independently of the main field flux, it induces voltage in each phase which lags the respective phase current by 90 degrees. Hence the armature reaction causes an armature reactance drop, which will be considered later when we consider the practical generator with all the winding resistance drop, reactance drop and the armature reactance drop, so that what will be the terminal voltage of the given practical generator. So what all we have discussed today is basically about the armature reaction. So first we tried to understand that what is the characteristics of the armature field, then how the armature reaction is being introduced, and then the armature reaction for different types of the load with unity power factor, 0 power factor lagging, 0 power factor leading.